Okay, so for this late afternoon presentation, it's my great pleasure to introduce Ganapati Baskaran, and he is actually a distinguished professor at the Madras Institute of Technology, and he's also professor at the Perimeter Institute in Waterloo. And he will tell us about boson bloom. Please.
Thank you, Professor. So very good evening to everybody. So I feel honored to be talking to you today. Thank you, Abhishek, Dhar, and Rajesh and Spenta for organizing this wonderful event and inviting me to give a talk. So it's really a pleasure to be here. So it'll be a very light talk with stories and maybe jokes and so on. So please enjoy. I think you have heard enough number of technical talks. I have heard enough number of technical talks since morning. So feel free to stop me if I am not clear. Even though Rajesh will tell that please ask the questions at the end. Okay, so here is a beautiful picture of sun, flowers. I think roughly there's about 100, I have not counted. There are 100 flowers. So I'm going to talk about this topic, boson bloom. It turned out that I gave a talk 3 years ago at IISc Bengaluru in a conference on superconductivity and novel spectroscopy. I gave a historical overview of Indian contribution to spectroscopy, starting from Raman and so on. So Tanushree Dasgupta, who is the director of SN Bose Center, she listened to my talk. She commissioned me that I should write about Bose. So I told her, I like Professor SN Bose, but I don't know much about him. She said, you should write. So I wrote an article along with Alex May. I will give the reference at the end. So that's the origin of this article, boson bloom. So, okay, this is what I plan to do, quantum physics and blooming of international cooperation, Bose-Einstein bond, how it made a difference, then blooming bosons, post-condensation, anions, and so on. And also, I will spend some time, maybe 5-10 minutes, about Bose as a great scientist and a wonderful human being. Now, I remember when I was a student at Bangalore, not long back, in early 70s, I had the honor, pleasure of having Professor Mukunda as my teacher. He gave a wonderful course on several things. And in 1974, if I remember correctly, SN Bose passed away at the age of 80. So we had talks by various people, including, I think, Professor Mukunda wrote an article in Resonance. ECG Sudarshan wrote an article. Professor Ramaseshan gave a talk. So it was inspiring to learn about SN Bose. But also, as a graduate student, I had learned about Bose-Einstein statistics, worked through the derivation of Bose condensation. It was beautiful mathematics by Einstein. And also, I was very familiar with Bose superfluidity and so on. So Bose was always in my mind. Then I did my first paper on interacting bosons, namely interaction between plasmon and magnons in magnetic semiconductors. I call that as my theory of weak interaction, because it turned out those two bosons interacted very weakly. So that was in 1973. But I'm very happy to see after 50 years that paper got citation recently, because thanks to advancement in technology, they have been able to see it experimentally, thanks to plasmonics and so on. So nothing is weak. Okay. Now, here is Dr. Mani Bhaumik. He's sitting here. Here is Dr. Mani Bhaumik. Oh, yeah. So I was thinking sometimes back about people who have the pleasure of meeting SN Bose. So I knew Partha Ghosh. Then today I learned that from Suparna, who is sitting here, her mother, Purnima Sinha, was a student of Professor SN Bose. So she has interesting stories to tell about SN Bose, so you should ask her to give a talk. So just I learned about it 10 minutes before the talk. So then I learned Mani Bhaumik was, it was very interesting. See, I read archive regularly. Every morning, I don't read newspaper, I look at Condensed Matter archive and various things. It gives a feeling of what's going on. Newspaper give you negative things, they don't. So all Then I found an article by Professor Baumik about quantum entanglement and Einstein-Rosen bridge. And it said Mani Baumik Institute of Theoretical Physics, UCLA. Then I became curious and I found out about him. So Mani Baumik was inspired by S.N. Bose as a young person. His dad was a freedom fighter, he was in jail. It's a very interesting story. I request you to look at the website. He is an admirer of S.N. Bose. So once I saw his paper, I sent him a note to him saying that I'm at Los Angeles, I would like to meet him. He invited me. So he gave me a good dinner and so on. Then I invited him to Perimeter. Last year, he was at Perimeter. He spent a week, it was wonderful for us. So Mani Baumik is inventor of LASIK, laser eye surgery. So photon is an eye opener, right? So if you have, a healing touch, it makes blind people see. Then one day he invited me for a dinner. I told him, Professor Baumik, why don't you come to my daughter's house? She lives about 60 miles away. So he kindly agreed. He accepted our simple dinner cooked by my wife, White Rose. So this is the Bose condensation of international crowd. This is, him, Razibul Islam, a quantum guy. He builds ion traps. Then that's Baumik. This is Tony Lee from Perimeter Institute. This is Crystal from Greece, wife of Razibul. So my grandchildren, my son-in-law and daughter, and they are very fond of this. They ignore us to the extent that they take care of this more than the parents are. Anyway, so this is Bose condensation, Mississauga. So I don't want to give a serious talk, it's very, okay. So I'm from Institute of Mathematical Sciences. You can see a green campus, but just 10-acre campus. But this is a photo I took of, and in some season you have these beautiful blooming flowers. It starts in February and stays till about May. And then we have this pandal, a hut. And then now, for the last 6 years, I'm associated with IIT Madras, where you have to respect this crossing deers. Cars are allowed to go not beyond 20 kilometers. That's the speed limit. And then we have this banyan tree and this rare black buck. Then these are, students call it as professors. We call it as students. So it's descended. So, it depends. So they visit us occasionally. Then I have this good association with Perimeter Institute for the last 11 years. It's a great place. On the green park, a little zoo and an artificial lake. Many of you may have come there. It's a beautiful place, ducks and so on. And I like this place for the reason, it's a research institute similar to Math Science, but external visitors program, and they have 1-year program. It's an example of a respect by an individual for theoretical physics and science as something that helps transform society. To me, Mike Lazard is an example. He's a billionaire. He founded BlackBerry and so on. So one day I had the pleasure of talking to him for half an hour. He says, look at Maxwell's equation. So what did Maxwell do? There was Gauss's law, Biot-Savart law, Ampere's law, and so on. He put them together. There was no reason we should have tried to put them together, and gave it to the hands of calculus. It gave him Maxwell's wave equation. And he told him that from zero length to infinite length, there are electromagnetic radiation which propagates with the same velocity. He was also shocked to find it's a velocity of light. At that time, nobody connected light with electromagnetic radiation. And even Faraday apparently did not believe the prediction. 20 years down the line, Marconi discovered it. Hertz. Then 20 years later, J.C. Bose and Marconi started electromagnetic communication. The world is different now. So he says, we have to help open-ended science, and that's why he started Perimeter Institute with a donation of about $150 million. He's given about $500 million. And we have outstanding people, including Professor Mani Baumik, who is here, and so on. So it's very important in the future not to rely on government. There are many, many enlightened individuals. Please sensitize them, and science will grow. Okay. Now, also, it's my wish that educated institution, like ICTS, and I like it because it's in the midst of, when I go out, I see the cows. I'm reminded of my younger days. and I used to go behind buffaloes and so on, cows and fields, and there are birds. Yesterday I saw some kind of honey sucker. What is it called? Hummingbird. Amazing, beautiful thing. So this how, so like IIT Madras is like that, and Perimeter Institute, close to nature and alive with life. So educational institutes are temples of learning. So traditionally, place of worship are housed in sacred groves. In India we call it sacred grove. They are in China also. So they are sanctuary for rare species of plants, homes for birds, and so on. So that's how educational institute should be, in my opinion, in every place. So keep it in mind when you grow your own institute. Science has been undergoing an unusually long and intense revolution in the last 100 years. We can partly attribute this to our understanding of the quantum secret of nature. I think, starting with Rajesh Gopakumar, when he gave the talk, he alluded to this kind of thing. And also, if you look at quantum mechanics, it's an amazing discovery, inspired guess. You look at some experiments, they tell you something, you make some guess, inspired guess, then nature seems to follow that. So it's one of the greatest creative act of human mind. We all agree. We have literatures and arts and so on. They are all great. But, and also what is amazing is, this is what I think. In my opinion, that's what Rajesh was also pointing out, that quantum mechanics or science in general has unified humanity, and scientists are messengers of peace. For example, if you look at this Planck, Einstein, Bohr, and S.N. Bose, in fact, according to Dirac, in the line of discoveries, important discoveries, S.N. Bose is the fourth, following Planck, Einstein, and Bohr. So that was the beginning. Then that gave rise to wave mechanics, de Broglie, Schrodinger, and so on. So it's very clear it's a collective effort, unique in human history. Never before this quantum phenomena, humans collaborated so much across the continent. Now look at Raman, Yukawa, Salam, Dyson, everybody collaborating, and many things happening, and S.N. Bose, and the beautiful bonding between Bose and Einstein. So this was all started because of quantum. So quantum in some sense a great unifier. So a forerunner to the collective international character of modern science. Now if you look at it, the ICTS that I'm standing here, and you guys represent this collective character. There are people from Germany, people from various countries in the world. And ICTP, Abdul Salam, started, I will tell a little bit about later. Institute for Advanced Study at Princeton, African Institute of Mathematical Sciences, started by Neil Turok, and it has grown into many, many. Perimeter Institute, KATP. Then, International Center for Material Research in Jawaharlal Center, ICTS, IITM in Zanzibar, and so on. Let me talk about LHC. We had a nice talk about high energy physics by a colleague before. Apparently, never before in the LHC, there are about 2,000 employees from 70 countries. They discovered, apart from Higgs particles, they gave way to World Wide Web and so on. So never before humanity has collaborated so much. So this is thanks to quantum mechanics in some sense. Similarly, this E8, it's called an exceptional group. Amazingly, to classify irreducible representation, thousands of mathematicians all over the world collaborated. It would never have been possible before. Similarly, Human Genome Project. At a personal level, I am a beneficiary of quantum mechanics in some sense, because when I was doing my master's in Madurai American College, it was 1969, summer, or I don't remember. My professor Rees came to me and asked me, Baskaran, what are your plans? I had no plans. I told him I will become a demonstrator in a college. Suppose you don't get it. I told him Madurai University has advertised for a scholarship, research scholarship with 200 rupees per month. Suppose you don't get that. So I scratched my head. I had no answer. And he said, do you know about Indians of Science at Bangalore? I told him no. Have you heard about it? No. Okay. Do you read newspaper? No. So please read the newspapers for the sake of advertisement. In March, the advertisement will come and apply. That's how I entered Indian Sub-Science, thanks to Professor Rees. Rees was a remarkable person. He was a scientist at Bell Telephone Labs, working in the semiconductor division on spectroscopy. So he was a great quantum mechanic and experimentalist and so on. So he inspired us about quantum mechanics, and he showed me the way. Then I met Michael Berry at IAC. It was, I think, Rajaram Nityananda is here. It was 1976. I think Michael gave about 20 lectures starting from wave singularities and caustics, quantum chaos, and a variety of things, except for Berry phase because it does not come. So it was so that at the end of Michael's talk, Rajaram Nityananda explained to me what I learned that day. So that's how it went on. So it was a great time. Then I met area society at ICTP. We became on a boat journey from Trieste to Yugoslavia. That was one thing, a memorable trip, because see, we Indians have a problem for getting visa for any country. So thanks to Tito Nehru alliance, we could go to Yugoslavia without any visa. So I often went to Yugoslavia as much as possible. Every week I used to go there, take a boat. So once I met area society, we had good time. We became friends and collaborator. Then I met P.W. Anderson, Walter Cohn, David Cross, and so on, Yulu. So it's amazing quantum mechanics has influenced our life in various ways. Anyway, okay, life is inseparable from light. This is a beautiful picture. I was 2 years ago. I was traveling from Los Angeles to San Francisco with my family, and we stopped somewhere. We took a side road. We saw these beautiful flower fields. So this is a picture. Look at the. I think I have more pictures, but I will not show it now. Similarly, this morning I took about 20 pictures yesterday evening of different flowers in ICT campus. Then I remembered my wife's warning. She tells me that if you look at my self camera, there are no human beings, only flowers and plants and other things are there. So anyway, I will show only one. Okay. Light enlightens. Over centuries, it has illuminated our path to understanding our physical universe. Efforts to understand black body radiation gave birth to quantum mechanics. Same light revealed the secrets of space-time through special theory of relativity, Lorentz invariance of Maxwell's equation. And light is a visible manifestation of quantum mechanics. Now I remember a beautiful lecture by Professor Mukunda, where he was reviewing work by Majorana, where Majorana interprets Maxwell's equation as a wave function, Schrodinger equation for a photon. Then you may ask, where is Planck's constant? It appears on both sides, it cancels because the mass is 0. So there is a whole approach to, so in some sense, Maxwell's equation predates quantum physics because it is a wave equation in which A mu is the variable and so on. Anyway, A mu is like the wave function, vectorial wave function. So that is it's a visible manifestation of quantum mechanics. Light enlightens, sorry for the PJ. So black body radiation, Planck distribution, you all know that. But what is fascinating is the distant sky at night from the end of the universe or the beginning of the universe is a black body radiation 3 Kelvin. Nothing can be a perfect fit. This is supposed to be from the experiment. 3-degree background, so it speaks for Bose and Bose-Einstein distribution and so on. Now, okay, now let me come to the actual story. So it starts nearly 100 years ago. Young Bose, working in Dhaka, he is teaching quantum physics. So he is not very happy about the way Planck's distribution is derived. So he has his own way of doing it. So he writes an article and sends it to Einstein, and these two people are, so when somebody's face appears in India in the stamp, then he is really great. That's something important. Like, 1 rupee stamp, and this also 1 rupee stamp. Now nobody sees stamp. So, and interestingly, you see not Planck's distribution, but general theory of relativity, gamma, mu, nu, alpha, and so on. And actually, when Bose sent the article to Einstein, he sent this apparently, told him that he and Saha translated Einstein's and Minkowski's paper on theory of relativity. So that was the way he introduced himself, from Germany to English. Okay. So this is the abstract of the article. So he gives a very brief abstract by Bose. What is interesting is the following. If you look through the paper, it's available in the internet. This author has recognized the logical deficiencies of all previous derivations and attempts to deduce a formula without reference to classical theory. That is Einstein. So he Bose talks about Einstein. Then, however, Bose goes deeper and he says, even Einstein's derivation, there is a logical inconsistency. So he says, Wien's law is based on the classical theory, and the correspondence principle supposes that the quantum theory be in agreement with the classical theory in certain limits. So in all cases, it seems to me that the derivation are not justified in a sufficient logical manner. So he criticizes Einstein in a positive way, and Einstein takes it in again a positive way, and that's the beginning of their relation. Okay, then I have an interlude. Let's see what is it. So the international connection is so important, like the connection that we are here, you meet and so on. I don't know about the future. Fantastic things are going to happen. Sommerfeld apparently visited Raman, but then in those days you had to come by ship. So get down at Chennai and take a train or something. So Sommerfeld got down at Chennai, and then he gave a talk at Presidency College, and he talked about theory of specific heat of metals and Fermi C. And young Chandrasekhar was in the audience, undergraduate student. He listened to it very intently, very carefully, and then he generalized it to relativistic situation, and the rest is history. So black holes and so on. So that's the advantage of this kind of meetings. You don't know what's going to happen. Many nice collaborations and many things will happen. So these are all, many advances. Okay. How am I doing with respect to time? Okay. I will come to them. There are two great statisticians India has produced. One is S.N. Bose. Another, I don't know how many of you recognize him. His name is C.R. Rao. Recently, some of his works have become very famous in the context of quantum theory, Kramer's Rao bound. So he died at the young age of 102 last year or so. Amazing. I have heard him when he was 90. He visited IIT Madras many years ago. Give a beautiful talk about joy of mathematics. It was really a pleasure to listen to him. So that was C.R. Rao. And this is S.N. Bose, Saha, I think Mohanlal. These three great people at that time. Okay. Now the zoo of elementary particles. Already we had a lecture by our colleague about these quarks, up, down, charm, strange, and top, down, bottom, and neutrinos, 3 generations, electron, muon, and so on, and then photon. What is interesting is, so there is a bloom of bosons. So standard model unifies weak electromagnetic strong interaction. Higgs boson gives mass to all elementary particles via Anderson-Higgs mechanism. It's amazing how the idea of Bose condensation, London's appreciation of superfluidity of helium-4 as Bose condensation, then later Ogh's appreciation of what he observed to be 200 Kelvin superconductivity in metal ammonia solution. As Ogh said that 2 electrons will form a pair and it will behave like a boson. Later, of course, Cooper formalized it in a beautiful way without knowing the work by Ogh. So the Bose condensation was already known before, a possibility of electron pair already known before to quantum chemists like Ogh. So beautiful connection of Bose-Einstein condensation and so on. Okay, this happened. Okay, now behind the standard model is Great Salam, and in fact, now in India and China, we have mature theoretical physics community institutes like this. But 50 years ago or 60 years ago, we were not, our theoretical physics was growing. So ICTP played a very important catalytic role. In fact, I have met all my theoretical physics colleagues for the first time only in ICTP. Only later I met them in India. So, and I remember Salam inviting us when I first went to 1976 for a school. He gave a brief talk. He said that it's an opportunity for you people to be the best mind from the world. Now it's for you to perform. Work hard and enjoy your stay. Work hard and enjoy your stay. I don't know how but it was enjoyable. Anyway, so then after 1 month, we had office, because at that time, about 4 or 5 of us were sitting in one office. So I found an elderly gentleman next door very often. So I asked somebody, who is this? He said, don't you know? He's Paul Dirac. Then I remembered Salam's statement. ICTS duty is put you together with the best scientists from the world. The rest is your effort. And also you to perform. I didn't know what to perform. I performed some dance, that's all. Okay. Now, then comes more is different, Anderson's famous and condensed matter. So you have fermions and bosons, photon, meson, and so on. Then came electron and hole, composite fermion, composite boson, Goldstone modes. In fact, it's Einstein's phonon. It's not a Goldstone mode, but Einstein oscillator. Then Debye made it into a Goldstone mode. Magnon, exciton, trion, polariton. And trion is not a boson, sorry, it's a fermion. And so on. And emergent particles, we have experts on cold atoms, ion traps, and so on. So not beyond solid state, you can have cold atoms, artificial systems, ion traps, where you can realize many of these dreams of models and real things in the experiments. Then the beautiful idea of quantum number fraction, which came with Sue-Schiefer-Hugert model and RBB theory and so on, Laughlin's theory, fractional quantum Hall effect. Even we're talking about graviton. Duncan Haldane wrote a beautiful paper some years ago, which was not well appreciated. He wrote about a Chern-Simons theory for fractional quantum Hall effect, in which he said, if you are careful, it looks like a theory of quantum geometry. So there was a prediction, there is a spin tool like graviton. Now recently there are experimental and theoretical beautiful support for spin 2 particles present in fractional quantum Hall effect as a collective mode at low momentum. And my colleague Balram and his friends, they have written up, and also Ajit from ISER Pune, he's here somewhere. So they have written an article about supersymmetry. That means there is also a graviton, the boson, and also a fermionic graviton. So there is even a emergent supersymmetry in this thing. So fantastic things are happening in the field. Okay, Bose statistics and Bose-Einstein condensation heralded the beginning of macroscopic quantum phenomena, macroscopic quantum coherence, order in momentum space, London, half-diagonal long-range, Ransauer-Yang, superradiance, lasers, superfluidity, cold atoms, superconductivity, and so on. Boson bunching, Hanbury-Brown tools, boson sampling, and quantum computing. So, I will not talk about, I think I have no time to talk about Bose. I want to talk a little bit about this so-called boson sampling method, but since there is no time, I will go to the personal aspects of Bose. So, there are many, Urbasi talked about many of these things. So qubits are nuclear spin, electron spin, cold atoms, and biology, electron nuclear spin. There are many, many possibilities. Let me skip this and then, okay. This is Bose's journey, increasingly passionate about Indian independence and then 200 years of British rule. When this finally occurred, he was elated but could not accept the partition of Bengal and India. In 1962, he supposed to have gone to Moscow, Sweden, and so on. And he was, okay. Now, this is the historical thing. This is a picture that I got from S.N. Bose archive. This is Bose and Dirac. Apparently, Dirac visited. So Dirac had a great admiration for Bose's work. Dirac coined the name Boson and also fermion to describe the family of indistinguishable particles whose many particle wave functions are symmetric under the interchange of coordinates of any two particles. Apparently, Dirac was surprised that Bose was not a fellow of the Royal Society of London. It was shortly after Dirac's visit that S.N. Bose and S.K. Mitra, a later well known for his pioneering research on radio and wireless, were elected belatedly 1958 as fellow of the Royal Society. So that was the visit of Dirac. There's a beautiful article by Ramaseshan. I will give the reference at the end. And also, I think Ramaseshan gave a talk about it in 1976. Professor Mukunda reminded me today. So, Raman and Bose were very good friends, and they had a lot of mutual admiration. Apparently, Bose writes somewhere that, in fact, I was so impressed with the discovery that when we were on a walk along the Hooghly, I told him near a ghat, Professor Raman, you have made a great discovery. You will surely get the Nobel Prize for it. That was a instant remark of Bose to Raman. Now, another thing. In their famous paper, which confirmed experimentally presence of quantized angular momentum carried by photon particle, Raman and Bhagavantam state. This is a beautiful history. In the paper that Bose communicated to Einstein, he had a factor of 2. Basically, Bose assumed that photon is a particle which carries a spin which corresponds to half plus h and minus h, because it's a spin one particle, but its one direction is always fixed along the direction of the motion because of the zero mass condition. So he had put some angular momentum quantization, but Einstein probably thought that he's saying something more important, so he removed that part. So apparently Raman knew that. So we understood from a personal communication from Professor Bose that he envisaged the possibility of the photon quanta possessing, besides energy h nu and linear momentum, also an intrinsic spin or angular momentum plus or minus 2h pi around an axis parallel to the direction of motion. So that means Bose, in his mind, had a particle picture of photon, which are indistinguishable. They also carried a spin the way electrons carry a spin. It's amazing. Okay. So quantum entanglement, we're all familiar with this. Boson sampling. Okay, I think this is the end of. So a scientist, however great his achievement is, a human being. Bose's greatness is visible in the anecdote described by Ramasation. I will give the reference later. I told that Bose that it was the only statement in a scientific journal that he had proposed for the first time that photon had a spin. I asked him whether something should be done so that he be given the credit for proposing the existence of the spin of the photon for the first time. Bose suddenly showed some annoyance. We are descending from the sacred to the profane, as the saying goes. That's what. So what is important, this is what Bose says. What is important is whether a photon has a spin, and it's not important as to who proposed it first and when. The high aims of science gets very debased by such talks of priority, etc. That was the statement from Bose. I told him that I stand rebuked, but my respect for the man went up greatly. Now I have to punish you. You have to listen to my playing the Esraj. It was a delightful ending. After half an hour of Esraj, I rose and said goodbye. So I learned from Suprana that he enjoyed playing Esraj. He also composed music. He also was fond of cats. Yet apparently he loved cats more than physics. Okay, I think I will finish 2 minutes before my time. So Bose played Esraj and Einstein violin. And Bose statistics and Bose-Einstein phenomena continue to provide music to our ears. That's my end. Then before that, I end. This article, thanks to my collaborator Robert May, I have not met him. It's a distant collaboration. I've only communicated with him. I have not met him. He's working in a company who make metamaterials and so on. So this is the article that has appeared in, so you can do a Google search, Google Scholar, Boson Bloom, you will get the free article. The edifice of modern quantum field theory, many-body quantum theory, quantum information, and quantum computing are built on bosons and fermions. They were blooming quantum garden of bosons as photons, gluons, and so on. So it's a part of the abstract. Now, there are very beautiful description of Bose's work, The Man and His Work by Chatterjee. Chanchal Majumdar and Partho Ghosh and Chatterjee, they have, that's a book edited by them. Then Kameshwar Wali has a beautiful book, Satyendranath Bose, his lifetimes, and also his selected works with commentary. If you look at Bose's work, it's amazing. He is not just a theorist. He's worked on mineralogy, and I learned from Suprana, his mother was a student, Purnima Sinha. Okay. She was, her PhD thesis was on X-ray crystallography. They built X-ray machine, so with the help of S.N. Bose. So he was a kind of scientist of classical times, doing experiment and theory together. Then Chanchal Venkatraman has a very nice book. Incidentally, Professor Venkatraman, who lives in Bengaluru, he has several books on this university press, on many of the things. Chandrasekhar and his limit and so on. Bose and his statistics, it's a wonderful book. Then Chanchal Majumdar has a book about Sudarshan. Then Ghosh. Then Professor Mukunda has 2 books, Current Science and Resonance. And most of these things are available here. So you can look at them. Thank you. This is a lot. So it's very interesting that about 20 years ago, the then director, I think what is his name? Sampath, right? No, Anand, M.S. Anand. He knew about Bose-Einstein connection. So, and also IIT Madras had a German connection because they were a nurturing country which was Germans. So, in memory of that, they named the guest house as Bose-Einstein Guest House. IIT Madras, so I wrote an article recently in one of the local magazines. IIT Madras epitomizes a 65-year-old bond between India and West Germany that started in 1959. Symbolically, one of the guest houses at IIT Madras was named Bose-Einstein Guest House. This year, 2024, marks the 100th anniversary of, and so on. So human bond has made a monumental contribution to modern science and technology. Thank you for your attention. I just finished.
Thank you very much for a very interesting talk. Are there questions? Historical remarks, maybe?
Yeah, one remark I wanted to make. There's a picture that you showed of Bose and Dirac.
Yeah.
So in that picture, actually, that's actually a truncated picture. The whole picture has my mother in it, and some others, another student of Bose, Tapan Rai and Gagan Banerjee. They were also there.
Oh, wonderful.
And that took place at the Great Eastern Hotel in Kolkata. So during Dirac's visit in the 1950s.
I see. So I don't know where I got this picture. I must have got it from one of
Yeah, originally from my mother, actually.
So maybe you can show the picture and then we can see. Can you show the picture again?
Yeah, sure.
Okay, are there more questions? No, maybe you wait for.
So she says it's only part of the picture.
Yes, yes.
There are others.
So to the right, extreme right, there was my mother was there. And Gagan Bihari Banerjee was a mathematician.
I see.
And Tapan Rai.
So you can see, not me.
Yeah, I have seen the original picture, which is with me. So, yeah.
Sorry, I think I suggest that we invite Suparna to talk in ICTS about this, because it will be very nice to have a personal, you have seen Bose or Professor Mani Baumik to give a talk about,
One more point, there is a SN Bose blog, which is maintained by Bose's grandson, Falguni Sarkar. So that has a lot of material on Bose.
Wonderful. In addition to the SN Bose archive. I see. Very nice. Thank you.
Okay. Are there other questions?
Yeah. Thank you.
Okay. Yes. Go ahead, please.
Oh, the Bose-Einstein meeting.
Did they ever meet? How long? What happened when they met?
Correct. Suparna, do you remember? Apparently, Bose did go to Germany.
Yes, they did meet.
Oh yeah. Sorry, there is a movie. Yeah, please.
Yeah, they have met.
They had met.
Yeah, and there's a movie that is going to be shown.
In fact, there is a movie that will be shown.
Okay, so we have to wait for the movie in order to see that particular instant.
Yeah, in a conference in Paris or sometimes, And I remember Bose had met Curie. He visited France and so on. Yeah, I have forgotten,
Okay, other questions? Well, that doesn't seem to be the case, so let's thank the speaker and thank also all speakers for the whole day. I mean, so here come Rajesh.